Let's talk about forces. Now there's lots of forces that we deal with in physics, but I just want to start out sort of with the beginning set. And I've come up with a mnemonic to help with it. F-tong, or F-town, depending upon the group who's going to be seeing this. These are the basic forces that we'll start with, and we'll slowly add as we go. We have this, we add a couple others. F stands for friction. T stands for tension. O stands for other. It's sort of a catch-all group, and I'll explain that as we go. N stands for normal force, and G stands for gravitational. Now, gravitational force, we have actually two varieties of gravitational force. There's one specifically called weight, and the other one is a more generalized gravitational force, and so I'm just going to write generalized. The symbols that I personally use for these, for friction, the symbol I use is what I call the Baroque F, sort of a curled F. For tension, I use F sub T. Now, in the past, I've just used a capital T for tension, and that really makes sense, and it's a lot easier. However, later on in the course, there's a formula that we use which involves tension and involves period, and the symbol for period is a capital T, since period is a time. And so instead of using capital T now, and then later on going, no, now I'm going to change what we've been doing, I'm going to start out with F sub T. Other is problem specific. The symbol for normal force here, I use a capital Y. I do it for two reasons. One, primarily because the high school physics textbook I used a capital Y, and it sort of stuck with me. And the other reason is that we don't use capital Y for anything else in this course. Potentially Young's modulus, but we're probably not going to cover Young's modulus this semester. Symbol for weight that I use is a lowercase w, not a capital W. That's used for watts and work. And then the generalized will do F with a subscript G here. So I'm going to give myself a little bit more space, and we're going to sort of set up a table here where we can look at a few other characteristics. That's a recap of what we've done already. Requirement, or requirements. This is what is necessary in order for this force to exist. For friction, there must be contact between two objects, and there must be desired relative motion. In other words, I have two objects that are touching each other, and if it were frictionless, would one object slide against the other one? That's the key question there. And we'll talk about desired relative motion as we go. Tension requires a taut rope, chain. It's a pulling force, so something that has to be pulling, rope, chain, etc. Other is, it needs to be, well, basically the requirement for other is that I have a force where I don't know the source or I don't care what the source is. So this requires unknown source or irrelevant source. The other typically shows up in a problem. For example, a 5 Newton force is pushing on a box. What's causing the 5 Newton force? We don't know. That would be the unknown source. Or when you're doing the force diagram, as we'll get into, if you're doing the force diagram, that there's something out there which, for instance, I have a pulley suspended from the ceiling. Is the ceiling important? Well, it depends upon the problem. So that would be a situation where potentially it's an irrelevant source. I know that the pulley is being held up. The fact that it's being held up by the ceiling, whether it matters or not, really depends upon the problem. Normal force requires contact. Matter of fact, friction, one of the requirements for friction is the fact that there is a normal force. And so I'm going to parenthetically put in here normal force. The generalized gravitational force just requires two masses. So there's a gravitational force between any two masses. For instance, there's a gravitational force between me and the camera at the moment, It's an incredibly tiny amount of force, and we don't have the equipment here to measure that small of a force. This is really the multi-million-dollar equipment, or really high precision if you go back far enough. So we ignore most of it. Usually we ignore the generalized force unless we are dealing with sort of on a planetary motion. Earth, Sun, gravitational force. We use the generalized gravitational force. Weight requires two masses, because that's true for gravitational force, but requires one small, and I can put small in quotation marks, one small mass and one huge mass. So I'm talking huge, I'm talking planet size or moon size. The small mass is anything that's small in comparison to the planet. So an elephant would be considered a small mass. Matter of fact, anything on the surface of the Earth is considered small. So those are the requirements for those forces to exist. Now, forces come in pairs, and I can safely say they always come in pairs. There's not a lot of always, and sure, the theorists can come up with some really bizarre exceptions, but ignoring those extreme cases, anything that we do, forces always come in pairs. And so since they come in pairs, there has to be some relationship between these two forces. And so the direction of the force, direction of each force in the pair with respect to each other. So for friction, the two forces are going to be anti-parallel. So they'll sort of be side by side in opposite directions. For tension, it is a pulling force. And so the two pair of forces will always be pointing towards each other. Others are situations, since we don't know the source or the source is irrelevant, we actually only draw one of the two forces, and so this is really not applicable, or it's problem dependent, however you want to look at it. Normal force is a pushing force, so the pair of forces are always away from each other. Gravitational force is always trying to attract things together, it's pulling things together, and so the pair of forces are always towards each other. And the last category is that I want to know the direction of the force with respect to the objects. Because the forces require two objects to be involved. There has to be a source and there has to be a receiver. Now that's reciprocal. Which one you consider the source and which one you consider the receiver depends on which force you're actually writing down in the pair. We'll get into that in more detail when we get to the force diagrams. So for friction, it is parallel to surfaces of contact, and there's two surfaces involved, as well as it opposes desired relative motion. And we will definitely get into more detail on that one. Tension is along the line of the taut rope, chain, string, whatever it happens to be pulling. Other is problem specific. For example, a 5 Newton force is pushing east on a box. Well, the direction of it is east on the box. Normal force is perpendicular to surfaces of contact. And then gravitational force is either one toward the center of mass of the other object. So if you understand this chart, then you got force diagrams, no problem. However, we will be going into loads of examples. And so I just wanted to start out with the basics. And I think this is in a PowerPoint too.